All right. Okay, for those of you who are fighting with graphing calculators, I started last year with 30 graphers up there, and they have been broken, stolen, or kids keep stabbing them in the back with a pencil and that grit gets stuck under them. When you see those that won't turn back on, it's because something is holding the reset button down, and I have to take the time out of my prep schedule to open them all up and clean them out. So if you need a graphing calculator, remember there is one on your laptop. Everyone has access to it. It is a TI-83 emulator. I have a handful of 83 loaners over here that may or may not work. Depends whether the battery is corroded because they're all old. There's one that works. There's one that works. Oh, my dang. Huh. I must have cleaned these up last year. Yeah, I got a whole stash of 83s here that work just fine. Okay. Oh. I suppose I should do some attendance. Let me see. Hey. Jack Avakai. Mariah. Q. Maddie. Max. Emma. Hayden. Got And not here. Canaan. Cali failed. And you get a car. And you get a car. And you get a car. You get a car. And you get a car. And you get a car. And you get a car. Everyone gets a car. And if you look at a thick packet of notes and you're like, oh no, this looks like a lot, that's like the next 10 days of in-class instruction. Okay? So, chillax. Bringing back 2014 for you. Anyone still rolling? We're there? Should be. Okay. First of all, round one, Castle Panic. It's a really good game. It's up there. Co-op. There are 5 orcs. We're going to have 3 of them coming at us. Does it matter which orcs are chosen? Does it matter that they're chosen first or second or third? No. An orc is an orc. Oh well. So combination 3. There are 4 trolls. We are choosing 3. There are 6 goblins. We are choosing 4. Grand total, there are 15 bad guys. And we are choosing 10 of them. So, calculatron, poke thing, alpha y equals gets me in fraction mode just in case, and I say, what is it, 5? Yeah. Parenthesis 5, alpha window 7. Wait, no, 8, combination. 3 of them, poke, thing, parenthesis, 4, alpha window, 8. Option 3, arrow over, parenthesis again, 6, alpha window, 8. We're choosing 4 of them. Move over, close parenthesis, downtown, 15, alpha window, option 8, 10. You get really good at this with time and experience. You poke the button and say 200 over 1001, or approximately, math changed to a decimal, because I can read this time, 19.98%. So we would say it is 200 over 1001. It is approximately 19.98%. Okay, round 2, state. The measures of central tendency and spread. Our measures of central tendency were mean, median, mode. Our measures of spread were range, variance, which I said we're just not even going to use. So if you didn't put it, don't worry about it. And standard deviation. Yep. I stat, I edit, I dump things in. Make sure all your numbers are good. To get your one variable stats, stat calculate, things, and there we go. I will say my mean is, well, first make sure we get the same thing, because sometimes when I'm putting the numbers in, I'll like fat finger it and call 6 as a 9 or 3 as a 5. Okay. 399.4 median is down here. 395. Mode, it will not give you. You got to look at the list and say who happened the most. And I don't see any repeats. So no mode. But for measure central tendency and spread, I have my standard deviation. Okay, now a couple kids did ask this. And it's a good question. It's a good clarification. I will take, right now, if you put either one of those. Okay? Because I didn't say this well enough yesterday, so that's on me. Big S, like with an S, that is your sample. Sigma, little sigma, O with the hairdo, is population. Sample is when you have part of a larger group. So that would be, I have collected a sample like, if I use this classroom as a sample of all students in the high school. Okay? A population, when I have the entirety of all possible objects. So usually what happens is we're going to use population because we're usually just given a set of numbers. The set of numbers is the entire population. The sample is when we say these 50 people were polled at the grocery store or something. Or they'll say 20 of the juniors did this. So if they just give you a number set, and that's it, just bracket, numbers. We should be using population because we have the entire population of whatever we're dealing with. Okay? So I didn't say that well enough yesterday, so if you have either one of those, you're good. Okay? So standard deviation, no, keep the colors the same now. We have cool tones down here. So if you had either 25185 or you had said 23.892, I'll take either one. It's really just in the formula, the only difference was if you divide by n or you divide by n minus 1. It's a really tiny thing, but it does affect it a little bit. So there's spread. Our other one was range. So I take maximum minus minimum. What's that? 54, 30, 84, 85? And I said we're not really going to care about variance. If you put variance, yay. Variance is just used to make standard deviation. Okay? So, did you... Here I'm going to say, did you set it up as probability? Stuff over stuff. Did you use combination instead of permutation? So naturally, if you use permutation, your numbers at the end are going to be wrong. You should get the correct answer if you put the right numbers in the right spots. Meaning you use 15 and 10 on the bottom, not 10 and 15. You used 5 with 3, not 5 with 4. You put the right numbers on the right spots, okay? So combination, probability, numbers are in the right spots. And then, did you list all the stuff, one as a floater for I accidentally used fat finger, right? Oops. All of my numbers are really, really, really close to that, but something was off. I go back to my list and find out that I called it 8 to 7 or something. Okay? So 3 for the first, 2 for the second. Questions on scourge? Okay. Womp. 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 Homework. We'll start with 0, 7. We got anything from 0, 7? I think there was one person who asked about the phone number one and how to start that. If you looked at the solutions, you'd see it's just exponents because you're able to reuse all the digits, so it's just you have 10 options each time. Nothing from the probability. From 0, 8 stats. Okay. All right. Oh, I'm good with that. Womp. We're going to jump into 1, 1 then, and we'll just get as far as we can get. So I know we kind of rushed through yesterday. I was a little more willing to put the foot on the gas and not actually go through every example explicitly because of how many of kids in this class and next hour are coming straight out of Algebra 2. Okay, so we should know all of our prob stat stuff. If not, it's on you to go back and remember some things. We're not going to use a ton of the prob stat stuff in here, like very minimal. Might pop up on the application problem every now and then. Where you do need to know it is that dreaded ACT. Guarantee they have it. Okay? You have to know what the different terms mean, how to find them. So we roll through them real quick. Oh, registration was yesterday. Everyone got her good for sophomores. So now juniors and sophomores should all be registered for next year. No questions about it. Y'all know what you're doing with your life. It sucks that we ask kids who are 15, 16, like, All right, what do you want to do for the next 50 years? But, all right then. Because we did that, because we really kind of zoomed, we actually earned an extra day. And that's good. Because second semester, we get a lot of interruptions. There's going to be the sophomore pre-ACT, where we're going to lose about a third of our class. There's the junior state assessments, Smarter Balance, D-Step, that kind of stuff. No, D-Step is in your chem class. Smarter Balance, we lose 2 days there. There's enough interruptions. Okay, so the more days that we can pick up like that, because hopefully we're all a little more proficient coming out of Algebra 2, the better. Every day that we earn is a potential day of review at the end before a final, is a potential day that our seniors in second hour don't have to do stuff on their own outside of class. Like, it's good. So, y'all got the notes. Jumping straight into one. Said we're not really concerned about when we break out a chapter. It's just keep going every 5 days. Number sets. This came up a couple of times, I believe, in 0. Something like what constitutes a rational, what is an integer. Maybe you just forgot the vocabulary terms. Okay. We start with, at the bottom of the pool, naturals. They're all just like a blurry double letter. Okay, that's their set symbol. A natural, that's Alabama math. You can count on your fingers and toes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? For whole numbers, all we do is add in 0. Okay? Naturals are 1 and above because they are things that you can physically count. You can count your M&Ms from 1 up. Okay? Integers. Probably one of the words that you've heard more than anything else in your math classes. Integers are positive and negative whole numbers. We're going to use integers an awful lot when it comes to multiples, because to be a multiple of thing, by definition, means something times an integer makes this. Okay. I don't like how they split up the table here. So outside of that is rationals. Rationals are anything that can be written as a fraction. And they give you a listing there. I mean, obviously, fractions are fractions. Why is 0.125 a fraction? How? Okay, if you just happen to know 1/8 off the top of your head. Place value, right? Tenths, hundredths, thousandths. 125 thousandths, 125 over 1,000. And then reduce it. Okay, so rationals, this is one where we might get hung up a little bit. It includes any repeating or terminating decimals. So if I ever have a decimal that terminates, that ends, 0.61829, done. There's nothing else after it. You put it over its place value. and then reduce it if you can. Repeating decimals. Now, point, bunch of sixes. Everyone knows that because it's drilled into you in probably elementary. Okay. What about No, write it as a fraction. Problem solve. How do you write it as a fraction? If you were in my class last semester, I'm really disappointed that you're not shouting it out right now. Because it's, no. It's 2/11. There was a trick that you learned way back in probably middle school, and then as soon as we gave you a calculator, you stopped doing it. You have forgotten the ancient magic. Okay? Yes, it's repeating. Just like with 0.6 repeating, I'll take 6, the repeating object, and put it over that many 9s to reduce it. I'll take the part that's repeating, put it over that many 9s, and reduce it. Okay? That's it. Okay? Now, if it's a compound, like it's 0.08 bunch of 3s, then you have to take the terminating part and the repeating part as separate fractions and add them. But if you don't know that particular trick from way back in middle school, what you can also do is oh, we got a double 8 in there. You just do that and then hit math fraction. Okay? So there are your number sets. The reason we got to know them, also, we went through our set stuff, right? One is within the other, is within the other, is within the other. So if I were to just say 5, what number sets does it belong to? Well, the most specific that I can call 5 is which set? Naturals, all the way in. But just like that little diagram that has like the shark eating the big fish, eating the little fish, eating the worm, like if that really happens, didn't the shark also eat the worm? Right? Everything is within. It's like those little Russian nesting dolls where the little thing pops out and the little thing pops out. If I have 5 is a natural, it's also in the circle of whole numbers and integers and rationals. Now I want to call it as specific as possible, but I have to understand that it also belongs to those other families. I don't want to say, good morning, mammal. Just because I'm right, technically, doesn't mean that I don't want to get a little more specific than that.
Good morning, hominid.
Right, that too. Okay. Now you can just keep going and going and going. I would probably want to use actual names. The last thing is irrationals. Suppose I missed that. If a rational can be written as a fraction, then an irrational cannot. The example they give is square root of 3, but there's some very famous examples of irrational numbers. Pi. We learned another one last year. E. Okay. I is not an irrational number because all of these, if you check the box, these are all a subset of real numbers. I, by definition, is not a real number. Okay? So, the reason we got to know that is because throughout PreCalc, we're going to be talking about analysis of functions, and we have to define what we're looking at. To do that, we're going to be using set builder and interval notation. Set builder, it's more of a thing that I go through so you know what's up when you get to proofs later on. But interval notation, that's the one we're going to use nonstop. Okay, set builder notation. You say it's all x's such that, and then you give a rule, and then you tell me what set it belongs to. Okay. Now, I used to think that, oh, maybe this is something you've just never seen before, and then I picked up an algebra half this year. We saw set builder notation all the way back in chapter 2 of algebra half. Okay. So if you did the combination algebra 1 in 8th grade, then it would have been in chapter 2. Actually, y'all are sophomores or juniors. When did they start using our books? That was about 3 or 4 years ago. Oh. Anyway, if you've seen it, you've seen it. If not, now you got it. When I say the rule can be something as simple as x equals 3n, where n is an integer. Now I'm talking about all multiples of 3. It could be an inequality. X is greater than 2. That is my rule. Okay? So set builder notation, you're going to use it a lot more in proof than in regular applications here in the class, but it's still something we got to know. Describe those in set builder notation. So I give you some examples, and then you're going to do it too. If I am given a specific set of numbers, all x's such that my rule, what would you say for a rule? What is a rule that describes this stuff? Greater than or equal to 8. Now, I got to be careful as to where I restrict it to. I want to be as specific as I can. I don't just say kids. Maybe it's high schoolers. Maybe it's juniors. So what's the most specific I can call this set? Naturals, all the way into finger and toes math. Okay, so I'll say where x is an element of the naturals. Remember that element of symbol? Now, if they give me an inequality, that just is my rule. All x's such that x is less than 7. But because this one didn't have a specific set with it, because they didn't give me examples, this is where you get to be a rules lawyer. What's a number less than 7? 6, 5, negative 20, pi over 18. And because I can't definitively point my finger at only these, I have to say where x is an element of the reals. Okay, so if they don't give you a specific set, you have to assume reals, and that'd be a good note to have. If they don't give you any specifics, you should be assuming that it's the real number set. Multiples of 3. Give me examples of multiples of 3. 3, 6, 9, 12, blah, 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 blah. What about negative 30? Could I count by 3s back to negative 30? Yeah. So these ones are a little trickier It's all x's such that x is going to be 3 times something. That's the definition of a multiple. I can take 3 times a thing, but that thing has to be very specific because can I take 3 times a half? And that's one of my multiples of 3. Is 1.5 a multiple of 3? Can I count by threes and hit 1.5? No. So I have to say that n is an element of the integers, positive and negative whole numbers. In fact, if you want to write next to this one, a good note is that whenever I have multiples, all x's such that x is something n, where n is an element of the integers. Your multiples of a thing are always written like that. You just change what's in the box. I can even say multiples of something that isn't an integer itself. Multiples of purple. What? Well, don't I have -3 purple, -2 purple, -1 purple, 0 purple, 1 purple, 2 purple? Yeah. Okay. I could do multiples of e. I could do multiples of square root of 5. And they would still fall into this pattern. So, I do some, you do some. ABC. And remember, you're talking to each other about this. Not about the game. Not about that one cute guy. Not about whatever class is up next. Like, chat it up about this. Argue about this. Well, once you're done with that, go ahead. Okay. Argue out the math. Tell your buddy, man, I'm hungry. I wish I had a donut right now. Now remember, set builder notation has all 3 parts. You can't just write 2 of the parts and think you're done. All 3 parts. All x's such that rule where set. Set up the same way. No, remember, you're saying that n is an integer because multiples of pi, the n will be an integer. All of my numbers will be irrational, yes. But the n I'm multiplying it by has to be an integer. Okay. All x is such that x is greater than or equal to 1, where x is an element of, as specific as you can, naturals. Oh, yeah. Wait, I thought you guys were gone today.
We leave in like 10 minutes.
Oh, okay. You don't have to weigh in, do you?
No, we already weighed in.
Got $1? All x is such that x is less than or equal to -3. Okay, get as specific as you can. I can't get more specific because there's all of the examples. I have to say x is an element of the reals. The multiples. Every time I see multiples, it is all x's such that x is something times n, where n is an element of the integers. It always follows that pattern. That's how you do multiples. And since I'm doing multiples of pi, it's pi times n. Okay? So, again, the numbers themselves, the multiples of pi, those will be irrational. But I have to multiply pi times 1, pi times 2, pi times 3 to get multiples of pi. Okay? It's kind of like multiples of pizza. How many pizzas do you have? Well, 1, 2, 3, 4, 5, 6, 7, 8. I got a big stack of pizzas. The pizza itself may not be a whole number. Okay. Okay, once we're past chapter 0, you're going to start seeing the little thumb thing a lot more. I want you to look at the ones at the bottom and just eyeball them. And you say, I can do that, I can do that, I can do that, I can do that. Oh, wait a second. What the? Are there any of those that just kind of a little sketchy? Not sure? Want to confirm an idea?
For number 1, would you just say that it'd be an integer?
That is integers, because I have positive and negative whole numbers. Yes, ma'am. What about the compound inequalities? That is your rule. All x's such that where x is an element of the reals. Okay? Yeah.
Are you allowed to put the or in there, or do you just have
Yeah.
to do? Okay.
Or is the operator for an or inequality. Yeah. All right. Well, the reason that you probably haven't seen that since beginning of algebra half is that mathematicians are notoriously not lazy, conservators of effort. We don't like writing things. You know, English is important, but math is importanter. We use interval notation most of the time. I know I've been making a concerted effort to put more interval notation in Algebra 2. I know that Mr. Spear does as well because I have PreCalc, he has Calc. So we see it in the upper levels a lot. We want kids to know it. I don't know if any of you who had work or McCreary for Algebra 2, if they're doing it or not. Interval notation is super easy. It's a parenthesis if it's not equal to. It's a bracket if it's equal to. And then you have your lower boundary and your upper boundary. That's it. So when I have something like x is greater than or equal to a. Well, a is the lowest it ever goes. And it says or equal to, so I put a bracket because I can equal a. The highest it ever goes is to infinity. And I have to put a parenthesis there because infinity is not a location. It's an idea. I can't actually equal infinity. I guarantee all of you you've at some point you got in that argument in elementary school or middle school. It was like, pew pew, I get you with my lasers. And he's like, nuh-uh, I got shields. And the next one's like, yeah, well, I have a dinosaur that eats shields. And the next guy says, yeah, well, I've got a nuclear bomb and it blows up the dinosaur. And you fired, and then I have protection from instance. I have protection from this. I have protection infinity. And then you get the kid that says infinity plus 1. And then you get the kid that says infinity times infinity. And then you get that pedantic little jerk who says infinity to the infinity power. And it just keeps escalating, right? You never actually see the end of it because infinity is an idea. I can't get to infinity because as soon as I get to where I think infinity is, there's infinity after it. So that's why we're always going to put a parenthesis on infinity, both positive and negative, because you can't touch infinity. Unless you want to get all philosophical about it. And you start talking about what constitutes nirvana. So, each of these, as a interval notation, in a compound inequality like this, they give me the lower boundary, they give me the upper boundary. I can't touch -8, but we can with 16. Ta-da! Done.
Wait, what do you mean? Oh,
Because it's not equal to. Remember, when I have a inequality that's really, really close to -8, but not equal to it, that is the annoying little sibling saying, I'm not touching you, I'm not touching you, I'm not touching you. Like -7.99999999999 is still bigger than -8. Okay? Who's got that sibling? Like they're so close that you can feel it like touching the hair on your forehead just because you're a mammal.
You're not touching me, so I'm gonna hit you a black eye.
But I'm gonna hit you anyway, right? Okay. Less than 11. Well, I know 11's an upper boundary and I cannot equal it. I know negative infinity is a lower boundary because it's anything less. And a parenthesis because I cannot equal negative infinity. I hate it when we have snow and rain in the parking lot. Squeak, 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 squeak. And then you get that one freshman who's just... I know. One of you does it. No? Okay. All right. Compound inequalities, if they're if they're headed in towards each other, they're nice and easy. Oh. Them's fighting words. If I say x is less than or equal to -16, negative infinity to -16, yeah. Greater than 5, so 5 to infinity, both parentheses because I can't touch either one. And it says or. Union. Remember that these are sets. Interval notation is a way to write a set. And sets can be joined or with a union. Get used to that notation because we are going to have interval notation with multiple unions for months. Okay? If you need to say multiple different locations, if you need to exclude a value, okay? Like what happens, y'all remember stuff like, I don't know, 5 over... Who's not allowed to the party? Who's not a part of the domain? 2. Thou shalt not divide by 0. So, I'd have negative infinity to 2. Can't touch this. And then 2 to infinity. You'd put that little union butt cheek on 2 to say this is the one thing that is not allowed. And I'll use parentheses to exclude it. Everyone else is allowed to the party, just not 2. Okay. So that is interval notation. Who what?
Could you union be like between twos as well?
Between twos.
So you can do 1.
What?
Like in that you can do 1. 1 minus 2 equals -1. That's fine to divide by that, but you just can't do 1. 2 itself.
Exactly. So negative infinity to 2.
Oh,
2 to infinity. So at 1.999999999 and 2.0000001, it makes math go. Okay? So, ABC. Give them a roll.
I think they just want to do it.
All those fails, you can sketch them on a number line too. That should show you what your interval looks like.
Yeah, we can do it. This is going to be better.
Greater than 9. Less than. No, we're not sleep deprived, not at all. Okay, I see a lower and upper boundary. The question is parentheses or brackets. -4, bracket, because it equals. -1, parenthesis, does not equal. A is greater than or equal to -3. So my lower boundary is -3 and it equals. But we can never touch infinity. Before I go putting parentheses or brackets on these, we know it's going to be a union, right? Did you remember to put them in this order? Why do I need to put them in that order?
Because negative, like you have to have negative.
Whenever you state a union of sets like this, it needs to read like a number line. You can't go from 9 to positive infinity to negative infinity. It should read like a number line. Okay? Womp womp. Okay, functions. Please tell me I'll remember from back in the day what constitutes a function. See, a relation is anything that just maps input to output. Okay? Okay. Relation. Who's got multiples? Who's got multiple siblings? Okay? Carter. Okay? If we have the sibling machine, the sibling relation, and we grab Carter and we chuck him into the relation, it spits out whose siblings? Yeah. This is the part where you name the siblings because that's your output because you map Carter to siblings. Hey, there we go. Okay. That is a relation, but it's not a function because a function maps one thing to one thing. Okay. And the way that I always think about that is a machine is supposed to be functional. Every button on the machine is supposed to do one thing. Assuming that I'm paying for it, if I put a $1 in the machine, and I poke the Mountain Dew button, boom, boom, spits out Mountain Dew. If I poke the Mountain Dew button again, what should happen? Another Mountain Dew, because it is a functional machine. But if I poke the button, Mountain Dew. Poke the button again, Cherry Coke. Besides, table flip, that is not a functional machine. If I lay on the horn to tell the guy in front of me that he needs to rethink his choices in life, and then I lay on the horn again and my windshield wipers start flopping, that machine is not functional. It's not doing what it's supposed to. To be a function, every input, which is a element of the domain, has to map to exactly one output, which is one element of the range. That's what makes a function. Is it a functional machine or not? Did I press the button, volume went up. I pressed the button again, the TV turned off. You would say this remote does not work. It is not functional. So, look at set A, set B. Is that a function? Does every element of the range map to one element of the domain? Does 1 only go to one place? Does 2 only go to one place? Does 3 only go to one place? 4 only goes to one place. Is it possible to have more than one Mountain Dew button on the machine? Is it possible to have more than one button on the remote that takes you back to Netflix? Yeah, you got the Netflix button, you have the previous button, you have the favorites button, like however you designed it. But if we don't talk about Bruno. If I hit that button, it does that thing. What would happen if I took this and flopped it around now? Now it would not be a function because 8 would be mapping back to two different things. Okay? You press the button, it unlocks your car. You press the button again and your trunk opened. Oops. Okay, it's not functional. The way that we see that graphically is, well, every input, that's an X. Every output is a Y. So if I pick the -5 button, I should only get one Y. If I pick the -1 button, I should only get one Y. But if I poke the 2 button, I put 2 into the function, and I get plus or minus 3, now it is no longer a function because it did 2 different things mapped to that input. Which is why you know that a parabola is a function, but if I turn that parabola on its side, it's no longer a function. That's why we restricted the range for square root functions, so it would still be a function. So, that's our definition. You tell me which of these are or are not functions. Okay. A, I put your ID number into Campus. It spits out a score on a physics exam. Is that a function or not? See, you might be thinking of exceptions to the rule right now. Tell you a little life hack for high school. I hope that you haven't had to learn this the hard way by now. Teachers love when you qualify your answers. When you write something in the margin next to the answer to explain your answer. Because even if your answer is wrong, maybe you write something next to it that says, okay, it could be this or this. It depends what you mean by a physics exam. If I see a kid do that on a test, oh yeah, I'm giving them credit. Because that shows me that you understand what the question is asking, but the answer is dependent upon my wording. I didn't clarify that enough. By all means, do it. It won't always get you credit, but you do that with most high school teachers and they're going to at least double think it. I say most because there are some teachers who say you did it a different way, you're wrong. If you've only taken one physics exam for the semester, that would be a function, right? Input name, one result. If you've taken 5 tests that semester, I put in your name, it spits out 5 different tests because it says on an exam. If they were to word this in not an atrocious way and say on a particular physics exam, now it's a function. Okay? In a table. Y'all remember the glorious quadrifecta here? Words, table, graph, equation. Yes or no? Is it or isn't it? Yes. Every one of my x values maps to one y value. So yes, yes, if, and then you qualify the statement. Definite no. How do I know if an equation is a function or not? If you can identify a reflection in it over a x-axis, then you know that that's not going to work. Remember, I'm looking at my outputs. Does every output come from only one input? So maybe I just rearrange this to get y by itself. And in the process of solving for y, I put a radical there. So I need a plus or a minus. This is not a function because when I put in 2, I'm going to get out plus or minus 3. So that is not a function. So that's the catch. You get y by itself. What does that function look like? Or what does that relation look like? And hopefully you're good enough with your graphs that you can tell me which it is. All right, top 4. A, B, C, D. Yes or no? If it's a no, tell me who the culprit is. Who's the one screwing stuff up? Why is it not a function? Argue it out with your neighbors. You think this, maybe it's that. Does this still charge? Even with that broke?
I think so.
Cool. So I love Casios. They're
Nice.
like $10 and they'll almost do your taxes. Those things are great. Okay. Oh, this is super random, but such is the bouncing ball. If you don't have a graphing calculator, I said you don't need one. You got a TI-83 emulator on your laptop. If you have an Android, not iPhone, because Apple is notoriously prickly about who gets to use their software. You have access to a free emulator. Okay, can I show you all the thing? It's like just Wabbit emulator, WABBIT. Like meh. TI-84 emulator for free. There are free graphing calculator emulators on App Store for iPhones, but they don't do. You either have to pay for the good one, or the free ones are missing some features. Like if we try to do regression past linear regression, it doesn't even have that option. If you are going past PreCalc, you know you're going past PreCalc, you know you're going to take STEM classes in college, then it's worth it to get one. It is a privilege to get one. You need money to get one. They're usually like 120, 130 bucks. If you do, wait for August and keep your eye on Target. Every year in August, when they start up their back to school junk, you can usually catch them with a TI-84 CE Plus down to $88. You know what? 40 bucks is 40 bucks. Okay. Otherwise, the TI-83s, you can get these. This is ancient tech. It works just fine. This does everything that you need to, all the way through college, on your ACT, everything. And it starts around, I think it's 80-ish. No idea? Okay. It starts around 80 right now at Walmart. This is the calculator I used in high school. Okay, and they haven't changed much from that to 84s. If you're willing to use a different operating system, Casios are better. They are menu-based. You just poke a button and it tells you the answer. They like Emma and Zoe last semester, they're just like, mine just does that. I don't have to poke all those buttons. Like, show off. So input is area code, output is a phone number in that area code. If I put in 605, is that only one phone number? No. In fact, y'all ever heard of a party line? The way that phones used to run? It was a single phone line that ran out to a neighborhood, and then that line branched into every house in that neighborhood. So when you called that number, it rang everyone in the neighborhood. They all picked up. And you'd be like, oh, don't worry, Kathy, it's for me. And theoretically, everyone was supposed to then hang up and you could talk to the person. But you'd hear that little buzz in the background. That meant someone was still there just listening to your conversation. Or you could be in the middle of talking to someone and someone would pick up their phone to call and they would hear you blabbing about the latest gossip and they would just listen in. So, the ancient days. Yes or no? If it's a no, who's the culprit? 5. 5 is mapping to 2 different values. 3C. Perfectly fine. What type of function is that? It is a cubic. I mean, no, it doesn't have the bend points in it. I was going to say, theoretically, it can be a quintic, can be a hexic, it can be any odd function. You'd have to have repeated factors and odd multiplicities, but that's stretching it. Y'all, this is just a line. It's just a line, so yes, it's a function. Okay, look down at the bottom there. And then I ask the question, how we feeling? And then you're like, I'm good, I'm great, I'm golden, let's move on. I'm a little fuzzy, I could use another example. Or, dude, what? All good? Okay. What about that one? Remember, vertical line test. Now, what happens if I was trying to look for its inverse? Does it pass a horizontal line test? It fails it infinitely, which means you have to restrict its arc function, which means the fourth commandment of domain. See in chapter 4. Okay. Function notation. Somewhere along the way, you have had a teacher tell you, probably down in middle school, probably in Algebra 1, you've had a teacher tell you that f of x is just a fancy y. Don't worry about it. That is incorrect. See, this is the name of the function. This is the input or domain. The rule that you put x into, and after I use this element of the domain, it will give me the element of the range. We all know from geometry, transitive property. Cut out the middleman. Okay? Every Friday, Sullivan brings donuts. If there are donuts, I will have breakfast. It is Friday, therefore, I will have breakfast. Right? Transitive property, you cut out the middleman. If f of x gets me the rule, which gets me the y, then I can just cut out the middleman and say that f of x is equivalent to y. They're talking about something in a different context, but they are talking about the same feature. It's the difference between saying, this is my finger and this is my thumb. One of them relates it to my entire hand, the other one relates it to its ability to oppose the rest of the digits. But they're both talking about the same object. Okay? Someone could say, hi, Jaden. Someone else could say, sup. And maybe your friends talk to you like that, I don't know. Aren't they still talking about the same person? Yeah? Okay. Don't do that. Jaden seems like a nice guy. Don't do that. So an equation versus a related function would be y equals 2x versus f of x is 2x. And f is just the name of the function. I can put whatever I want there. I can say g of x, h of x, lambda of t. Okay? Whatever it is, it's just the name of the function and the input variable. Independent variable. We talked about this with independent and dependent events. This is the input. This is the domain. It is what you control. Dependent variable is the output or range. And we have the commandments of domain that say, number 1, thou shalt not divide by 0. Number 2, thou shalt not take even root of negatives. Number 3, thou shalt not take log of non-positives. Number 4, stay tuned. We'll get that later. Okay, so getting used to the function notation, if I say g of x is this stuff, I have given you the rule. Everywhere in that rule that I see an x, I put the input. So g of 6 is g of 6 is. Everywhere there's an x, I'll put parentheses. Everywhere in those parentheses, I will put 6. Yes, you do want to use parentheses. Parentheses will keep you from screwing up your order of operations. I have seen it time and time and time and time again. If you don't use parentheses, you will screw up negatives, you will screw up exponents. So that's 36 plus 48 minus 24 is 24, 36, 60. Versus If I say g of x is x squared plus 8x minus 24, and now my input is a negative 4x. Do you see why I want those parentheses? I'm squaring the entirety of negative 4x. So that's 16x squared minus 32x minus 24. Square the entire part. And if you say that's a bigger number that you don't happen to know the square for, what if it was negative 17x going in instead? You don't know negative 17 squared off the top of your head, so you type negative 17 into your calculator. You didn't use parentheses. It spits out a negative 289. Ruh-roh. Okay, use the parentheses. Super important. Sometimes you got to put an entire expression in there, which is C. So we'll say g of x is squared plus 8 thing. Okay. If I'm plugging this entire thing in, 5c plus 4. Do not square like a freshman. If you say 25c plus squared plus 16, that is squaring like a freshman. It does not work that way. Remember, 5c plus 4 times 5c plus 4 gets 25c squared, 20c, 20c, and then 16. Okay? Oh, you can just leave it out if you want to. We're going to have to combine like terms anyway. So the trick for it is, we tried showing you this trick back in Algebra 1, whether you listened or not is a different matter. It's square the first term, square the second term, multiply these two and double it. Because you will have 2 of that term when you FOIL it out. And then 40c, 32 minus 24. Combine like terms. If you got to go old school on it, everywhere there's a plus or a minus, it's a new term. Turn that into 25c squared. 40c and 40c is 80c. 1632 is 48. 48 minus 24 is 24. Don't square like a freshman. Okay? Frank. ABC, let's see what you remember about rational functions. Particularly those of you who are just coming out of Algebra 2, this year is the first year we moved rational functions up to Algebra 2. It was a little bit tough for Algebra 1, and we saw way too many kids coming into PreCalc not knowing what a rational function even was. So if you had Algebra 2 last semester, this should be fresh in your memory. If you had Algebra 2 the previous year, then no, you didn't do this. Last time you would have saw this is Algebra 1. 12, 144, 120, 121, 5, 124, 27, 5. So 535. So 2, 8, negative 6a, 16, 3, 19, 9a squared. A squared negative 24a plus 6a is plus 18a. 5, 8, 64. 64 minus 16, 48, 49. And put a question mark on that last one. All right. 6a, 2, 8, 16, 19, yes. 9a squared, negative 24, negative 48. That's negative 48a plus 6a. Is that negative 42a in the middle?
Yeah.
Okay. Double checking everything, and that ain't right. The 49's good, though, right? Okay. All right. First and second one, I'm assuming we're okay. I hope. That third one. 2 by a thing plus 3. A thing squared minus 2 by a thing plus 1. The thing is negative 3a plus 8. So we get distribute negative 16a plus 16 plus 3. So I'll combine those last two. Square the first term. Square the second term. Multiply and double. Distribute. Combine like terms. Yay or nay? It's more just a matter of slow down and watch yourself through the algebra of it. Okay. Womp. There you go. Okay, so basically, can you algebra? But we got to review the algebra before we can do the mean stuff with the algebra. What?
Yeah, you said negative 6 to add. It says
Negative 6a, right?
You wrote 6.
Oh. Huh. Y'all good with that? Plug the stuff in. Use parentheses, watch yourself in the algebra. Okay. Yeah, we are going to cut it off there because we need to have a good long talk about domain. Which means your homework should already be correct on plan book.